regions. And there's going to be a fair bit of sketching in this, so get ready. But yeah, we're going to give it a try, and we're going to go with that. Lesson 52, feasible region. Today's fact. Take a guess at how many ways there are to arrange 52 playing cards. A lot of people, when I ask them this, they say, oh, there must be 52 ways. And some people go, oh, no, actually, I think it's actually not 52 because there's 52 cards. So there's 52 places. So they go 52 times 52. And that gives them, I think, 2,000, I don't know, what's 52 times 52? Let's do this in the calculator quick. 2,704. And I'm like, yeah, nice try. Guess there is a lot more than 2,704 ways. Because if you think about it, if you're trying to rearrange three things, there's already, you can go ABC, CBA, you can go BAC, you can go BCA, you can go CAB and ACB. So there are 6 ways to manipulate 3 things already. There are 10 ways to manipulate 4 things. So by the time you reach 52 playing cards, there are, get this, I love this fact, 52 playing cards can be rearranged this many ways. That's how many possible ways you can rearrange 52 playing cards. Then, whenever I show students this, I have some smart-ass student that says, well, how big is that? What is that? Can you even say that number? And so I got this. That is how you say that number. That is how big that number is. 80 unvigintillion, 658 vigintillion, 175. I'm not even going to read the whole thing. You can put this into Google and tell it to read it to you, and it can. The reason that it's so large is because it's actually not 52 times 52. It's 52 factorial. For those of you that don't know what factorial is, that means there are 52 cards, and there are 52 ways to put the first card. There are 51 places to put the second card. There are 50 places to put the third card. There are 49 places to put the fourth card, and so on and so on and so on, all the way and then until you get to the end. And when you multiply all that jazz together, you get a number that is 68 places long. That's how many numbers there are here. That's about the amount of atoms in the Milky Way galaxy. So if you go on all the Milky Way, that's how many. If each atom in the Milky Way galaxy had its own deck of cards, it could shuffle it. What's the beauty behind this story? Where's the magic here? The magic for this story is that the magic of this story that I like is that what that means is every time you pick up a deck of cards and you shuffle those decks, you shuffle that deck of cards, that means that you are holding, it's incredibly, incredibly, incredibly likely that you are holding an arrangement of cards that has never been made ever in the whole, in the whole of the human history. It's very likely, incredibly likely, that that arrangement has never been shuffled before, ever. And so therefore, if you ever want to be like, I want to discover something, I want to make something new in the world, grab a deck of cards, shuffle it, you will be the first person to ever shuffle the deck of cards in that way. And that's just because you shuffled it. This is, by the way, ignoring jokers. If you put jokers in, then it just increases by another factor of 50. What if your arrangement was actually already found? That is true. It is. It's not a 0 possibility, but there is a 1 in 80 vigintillion chance that it's, you know, that you have got a copy of someone else's. So it's very, very unlikely. Yeah, that would be embarrassing. I'm not reading the number for you, Adri. It's gonna take like forever. I've done it before. It's, yeah, if you, as I said,
do it again.
I don't even know what, like, I don't even know how to pronounce like that. I don't even know how to pronounce it correctly. Because actually, the thing is, Vigintillion, that's actually Latin. That's what makes it hard. Vigintillion is actually 20, is actually 20 in Latin. Vingent, I'm not, Vingent is Latin, and that unvigintillion means 1 plus 20 million. So you can see like some things here, like some Latin here. Sextillion. So sex means 6, dec means 10. That's 16 times, it's like 16, like, so you got 1000. Trillion means 3 copies of 1000. Quadrillion means 4 copies of 1000. Quintillion means 5, 6, 7, 8 copies of 1000. It's, yeah, I'm not reading it. It's going to take forever. No, I might, if you guys, at the very end, when I get send you guys off to start working on 12E, I may read it out for you if you really want me to, but I don't, it's going to take a long time. I prefer people trying to describe how long it would take to make all the decks, to make all the arrangements. But yeah, obviously, some arrangements are more popular than others. So if you've got ace to king in hearts, ace to king in queen, ace to king in diamonds, ace to king in spades, and ace to king in clubs, that's going to be arranged a lot, because that arrangement's probably going to be in most cardboard boxes of cards. But I'm talking about if you pick those cards up and you start doing riffle shuffles, then yeah. Oh my god! So someone said, so this game I play where you collect money and I've got them numbers. I thought it was just putting random letters in it. So yeah, it is. These are actual the numbers that actually go under Killian. That's 1 for individual, and then dec for 10. So then you got, so that's 11 million. That's 10. Yeah, so on and so forth. Okay, let's get to the actual lesson. Sorry, guys. I love random facts, though. That's why I do them. So, the feasible region. Will you be able to sketch the feasible region of multiple inequalities? So this is actually a continuation of what we've been doing the past couple of lessons. It's actually, I like, because what we're doing is we're building up level by level by level by level. So let's go back. What do I mean by building up? Well, at the very start, what we did was we started off by just random inequalities, right? How do we draw them on a line? Then we dealt with drawing them one-dimensional inequalities. So that's, you know, when you only have one variable. Then we started to, whatever, you have 2 variables. So that gives us lines that go up to the angle like, where is it, like this. So that is a 2-dimensional inequality. Now what we're doing is we're not, no, don't stress, we're not doing 3-dimensional inequalities, but what we're going to do is we're going to start taking 2 of these. So we're going to have crisscross regions. What does that mean? So what we're going to end up having is something like, let me see if I can draw it, something like this. And so we're going to have like, and then what we'll end up with is like something like this. So this doesn't get included, this gets shaded in. And so then we end up with a weird shape here in the middle. And we call that the feasible region. So that's what we're going to call it. We're going to do some maths on that. I'm going to show you how to create them and so on. Oh shit, I forgot to put this on there. A lot of students always ask me, because usually, because you know, I always have random conversations. Those students sometimes ask me what study score I got, and I think I put this up last year because I got sick of my year 11s at that time saying, "What did you get for maths? What type of study score you got?" So if you ever wanted to know, that's what I got. I think a lot of teachers are like, "Oh, you got to keep that stuff private." It's like, I don't care. I was pretty proud of it. I went to Melbourne Uni, and then a lot of students were like, "Well, I got above 95," and I'm like, 50% of my class got above 95. And I'm like, geez, I was impressed that I got 90.4. So yeah, that's my thing. French gets marked up like insane. By the way, those are the markups on the right. So the markups are on the right. So that's why I the point that I always said to students when I picked it is like, when I picked my subjects, I didn't pick them based on, I picked them smart. I picked subjects that I was good at, but also subjects that got marked up. My English I was actually surprised by. Like, I think I remember getting my English study score being like, how the hell did I get 35? I was like, I was getting ready to completely tank on completely tank. And it's out of all of the scores, I think it's the only one that went down. But it only went down a little bit. Whereas if you compare it to something like specialist maths, that stuff went up huge. My saying that I always said to students is, even if you fail specialist maths, it gets marked up 10. French gets marked up 11. I was like, I chose the subjects that I was good at, but also the subjects were marked up a lot. I was not a great specialist maths student. I really struggled, but yeah. But that's how I chose my VCE subjects, and that's what I always suggest to students is that you should always base your VCE subjects on 3 things: what you need, what you are good at or like, what you're good at, and then what gets scaled. Now, that most teachers tell you should not worry about what gets scaled. And I'm like, yeah, but honestly, if you want to get into, like, if you want to get into Melbourne Uni, you want to get to Monash Uni, whatever, it's kind of like, it's something you should think about. You should definitely never choose a subject just because it gets scaled up. You should choose it if you need it and you're good at it. Like, if you're good at maths, then if you're good at like a language, do the language. Anyway, oh crap. Now you guys know my middle name. I'm forever ashamed. You're saying this to me now. Someone's like, you're saying this to me now after I've already chosen the subjects. It's just, that's how I do it. That's how I did it. That's what they told me in school, and so that's why I chose them. And French, I was sort of liked French, and I was sort of good at it. But for me, the reason I chose French is because it got scaled. Because I was sort of good at it, and I sort of got scaled. Whereas the reason I chose the sciences is because and the maths is because I needed them and they were good at them. But the only reason I chose specialist because of all 3, because I was good at it, well, I needed it, and not because I got scaled. I think because it was just yeah. Anyway, yeah. Okay, let's keep going with the rest of the lessons. So, but yeah, just in case anyone ever. Yeah, right. I'm an open book. I'm not going to lie to you. Let's talk about, firstly, what's the word here that we're going to use here. So for the feasible region, what does that mean? The feasible region is a region containing all points containing all possible points. All points are possible or feasible. All points that we should be all points that are possible or feasible solutions to the set of inequalities. When dealing with multiple lines, don't shade the areas. When dealing with multiple lines, don't shade the areas you don't want to leave. You don't want to leave the feasible region. Oh my God, just don't write that down. Just don't write that down. Just stick with the first statement here, okay? The feasible region is the region containing all points that are possible or feasible solutions to the set of inequalities. Now, how we're going to draw these, and this is going to be important, is we're going to be drawing, and the reason that I'm going to say this is going to be important, how we're going to be tackling these is that we're going to be how we're going to be tackling them is we're going to be using we're going to be drawing the graphs, but we're also going to be we're not going to shade the feasible region. we're going to keep the feasible region blank, okay? And that's going to make it a lot easier for us to tell which region is the feasible region and which one isn't. So, and that's what I think I was trying to say in this section here, but I did a very bad job of saying it. So I'm just going to show you instead of saying it. This is a sort of an example of what it's going to look like, but we're going to do our own example. I've got 2 examples to go through. Now, and I'm going to go through 2 because I think it's going to be a bit better than going through 1. What I'm going to ask you guys to do is, yeah, okay, no, one sec. What I'm going to ask you guys to do is, could I get you to draw a Cartesian plane? You don't need to draw the full Cartesian plane. You just need to draw the positive area of the Cartesian plane. And I want you to also get down these equations here. So copy down these 4 equations. I'm going to do the same thing. I'm going to create a Cartesian plane, and then we're going to work on this together. I'm going to show you guys how we go about constructing a feasible region. Okay, I'm now going to pop open, I've now drawn enough, so I'm going to pop open the sharing my phones. Give me a sec so that I can project down here. And then we're going to walk through it. Let's check to see if you guys can actually see everything. You cannot at the moment. Let's just move my page. Actually, you know what I need to do? I need to move this. Oh, careful. Careful. There you go, that's better. Excellent. So we've got 4 inequalities here. Now that seems like a lot, but don't worry, we can pretty much ignore the first 2. And not all, this won't happen all the time, but a lot of the time you'll be able to ignore the first 2, because what these first 2 say is that x has to be greater than 0, y has to be greater than 0. That means those 2 lines essentially form this line here, because this line here, and you don't have you don't have to do this part here that I'm doing. I'm just showing you this part just so that no one gets confused here. That line there represents x is greater than or equal to 0. So all of this gets ignored. And then this line down the bottom here, again, remember, you don't have to do this. I'm just showing you just so that you've got everything. This line here is y is, I'm going to do this here, y is greater than or equal to 0. So all of this region here that's not shaded in, that's going to be, all that region that's not shaded in, that's where the feasible region could be. Okay, so now what we need to do is we need to tackle these bottom 2. So to tackle those bottom 2, we need to plot them on this graph. Now, there's a couple of ways we can plot these on the graph. what we're going to do, the last question is supposed to be y minus x is greater than 0. Oh, thanks for the save. Thank you for the save. Y minus, no, it should be, no, hold on. You know, I had it right. Y minus, so is the last question y minus x is greater than 1? Oh, yeah, you're right. Y minus x is meant to be greater than 1, not 0. So what we're going to do is we're going to plot. How we tackle this is we're going to go step by step. So what we've done is we've already done the first two. So now what we're going to do is we're going to try and do the next one here. X plus y must be less than or equal to 5. I'm going to do this one in green, but it doesn't matter. So how we plot this is the easiest way to plot this is to go x plus y equals 5. Now, I'm not sure if you guys remember this. I actually don't think I taught this method of sketching in the linear graphs topic. I actually don't remember, but we're going to use the intercept method. Did I teach you guys the intercept method? You guys remind me, did I teach you guys the intercept method? I'm trying to remember. If I didn't, hopefully you guys remember. If I didn't teach you, hopefully you guys remember. If you don't remember, we're going to be in for a bumpy ride. How you do the intercept method is you draw 2 points, except the points that you choose are your intercepts. So what we're going to do is we're going to choose 1 point. We're going to say let x equal 0. So if we let x equal 0, 0 plus y equals 5, y equals 5. There's 1 point, 0, 5. I'm going to put that on the graph, 0, 5. 1, 2, 3, 4, 5. And then my next point is going to be let y equal 0. This comes really in handy for these types of graphs. So then you go x plus 0 equals 5, x equals 5. That gives you 5, 0. I got that wrong. That should, whoopsies. I got these two wrong. Sorry about that. This one here is 5, 0. 1, 2, 1, 2, 3, 4, 5. That one there is 5, 0, 5. Geez, I'm making a mistake left, right, and center, guys. And then, okay, because it's greater than, right? You're gonna be careful. We're not gonna draw the line in solid. We're gonna draw the line in like so. Okay. Now the last step that we need to do to finish off this is we need to shade it in. So we're going to choose a point. I'm going to choose 0, 0. And I'm going to see, is this point 0, 0, is that in the region or outside of the region? Is it good or bad? So we can check that by just going, yeah, we're just going to check that by going 0 plus 0 is less than 5. Well, is 0 less than 5? You bet your bottom dollar 0 is less than 5. So if 0 is less than 5, oopsies, my screen is going blank. If 0 is less than 5, then that means that this is in the region. So if this is in the region, and this is not in the region. So this is the part that we crossed out. So at the moment, so far, this is just like, at the moment so far, this is just like 12E. If you haven't finished 12D. If you haven't finished 12D, then this is the same sort of thing. All we've done is we've plotted the points here. Now, if you didn't like how I did that, what you could do is you could turn this into y equals 5 minus x, and then put a point here at 0, 5, and plot a negative gradient like that. That would have worked too. You would have got the same line. Okay, so now we've got this. This looks like, so we've got an idea. The feasible region is going to be around here somewhere. But here's where it becomes different to what you guys have done before. What we're going to do now is we're now going to tackle this one here. Y minus x must be greater than 1. So how do we tackle that guy? Well, we do the same thing. Y minus x equals 1. I'm going to use the intercept method again. The reason why I use the intercept method is because both the x and the y are on the same side of the equation. So how do I do that? I go let x equals 0. That's going to give me y equals 1. That gives me the first point is 0, 1. 0, 1 is here. My next one I'm going to do is let y equals 0. So that means we've got 0 minus x equals 1. So therefore, x equals negative 1. The side? Shit. Huh. Well then, that's a bit unfortunate, isn't it? Because that's not on that graph. Okay. What do we do? What do we do? What do we do? What do we do? Well, man, okay, fine. Fine, fine, fine. Y equals, moving x to the other side, equals 1 plus x. M equals 1. So therefore, I've got a rise of 1, a run of 1. That fits me there. I can now draw a graph. By the way, for the record, this graph, this blue line here, does go through where negative 1 would be. If you want to cheat by extending the graph, you can do that there, but I just cheated. I just changed what I was doing and found the gradient, rearranged it to find the gradient. The last step is to check, which side is the good side and which side is the bad side. So the easiest way to do that is to choose a value. We're going to choose 0, 0 again. You can choose any value. Hopefully you guys understand that you can choose any value. We're going to choose 0, 0. So we're going to go 0, 0. We've got is 0 minus 0 greater than 1? Well, 0 is 0 greater than 1? No, 0 is not greater than 1. So therefore, this part down here is not in the region. So we're going to cross this out. I made another mistake, guys. Does anyone know what the mistake I made?
Dotted line.
What was that?
It's got to be a dotted line.
It was supposed to be a dotted line. Correct. Because it's, so I'm just going to do this because I'm a big cheat. So where is our feasible region? Our feasible region is here. This here is our feasible region because it's only in that section here where it works. So I'm actually going to draw this here. I'm going to draw a box that's blank. I'm going to write feasible region. And so that feasible region has a couple of points in it. But let's just experiment. 1, 2, 3. I'm actually going to experiment really quickly because I've just shown you guys how to do this. I'm just going to show you a quick little experiment here. The experiment that I'm going to do is I'm going to do this. we're going to take this point. This just is to further help you guys understand. 1, 2, 3. This point right here, 1, 3, is in the middle of the feasible region. So if that 1, 3 is in the middle of a feasible region, then that means it should work. It should satisfy each of these equations. Let's check. Is x greater than 0? 1 is greater than 0. Tick. Is y greater than 0? 3 is greater than 0. Tick. X plus y is less than 5. 1 plus 3 is less than 5. 4 is less than 5. Tick. That works. Next one. X minus y is greater than 1. No, y minus x is greater than 1. 3 minus 1 is greater than 1. 2 is greater than 1. Tick. It ticks all 4 of these boxes. All the rest of these regions, whether it be over here, here, will fail one of the conditions. For example, let's take one that fails more than 1. Let's take, actually, let's just take one that fails 1. So let's take this point here. Let's take 2, 1. Okay, if I take 2, 1, now you don't have to do this. I'm just trying to show you guys so you can get a full picture of what's going on. Is 2 greater than 0? Yes, it is. Is 1 greater than 0? Yes, it is. 2 plus 1 must be less than 5. 3 is less than 5. Yes, that works. Okay, the other one is 1 minus y minus x. 1 minus 2 must be greater than 1. 1 minus 2 is negative 1. Is negative 1 greater than 1? No, it's not. It fails one of the 4 tests. And because it fails one of the 4 tests, that means it's not in the feasible region. And I can tell that it's on the feasible region because it's in one of our crossed out lands. 2, 1 is here. It's in our crossed out lands. So we don't like that one. Now, the other one here is, of course, we could draw more lines, so you could actually have extra equations. And I've seen ones, you know, as we keep going, we're going to start learning how to add even more. So we've got 1, 2, 3, 1, 2, 3, 4 equations for this one. But we could have added 5 equations, 6 equations. It just would have been a bit more complicated. So that's our first example. I'm going to do another example to further cement this, even though we've got about 40 minutes. Do you guys need anything else explained here that I've done? Nope. All right, let's move on. So I'm going to go back to here for a meantime. What I'm going to get you guys to do is, could I get you, we're going to do this one here. We've got 4 more equations. I'm going to set this up. We're going to need to draw a new graph though, unfortunately. So I'm going to start drawing myself a new diagram, a bit of a bigger one actually this time, so I can fit it all in. In the meantime, I want you guys to jot down the equations and also, jot down the equations, and then we'll make a start in a minute or 2. All right. Let's give this next one a go, and we'll see how we go here. Again, there are lots of steps in this, and whether or not, and it's going to make a lot more sense once you guys start to play around with it. Now, importantly, I can't make any more mistakes. Why can't you make any more mistakes? Because I broke my white out. So it's going to be high pressure here, ladies and gents. I can maybe fix my white out, but I don't have time for that now. So let's give this a try and see how we go. So we're going to skip the first two here because x is greater than 0, y is greater than 0. That just means we're looking at this region here. So we're going to jump straight down to these two here. 3x plus y is less than or equal to 9, and x is greater than, oh, sorry, I got that wrong. Whoopsie. I said I can't make a mistake. Y is greater than or equal to 4 plus a half. So let's go with green, and we'll go with blue and black. So we'll go with black first, and we'll do this one here. 3x plus y must be less than or equal to 9. How do we plot this guy? Well, we can plot this guy by going 3x plus y equals 9. We're going to plot the line first. Now, what does this line look like? Well, we can plot this line by using the intercept method. So we go let x equals 0. That's going to give us 3 times 0 plus y equals 9, or y equals 9. So that gives us 0, 9. That happens to be our y-intercept, because it's 0 on the x and 9 on the y. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. It's a good idea. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a good idea to label your points as well, because as time goes on, and especially as these questions get harder, especially when next week when we start to really explore not just feasible region, but linear programming, we're going to need to be able to know what the coordinates are at certain points. And so the other one we're going to do is let y equals 0. So we've got 3x plus 0 equals 9. So 3x equals 9. X equals 3. I divide both sides by. I divided both sides by 3 to get to that answer. And then that's going to give us 3, 0 is our second point. So 1, 2, 3 on the x gets us this point on the x-axis, 3, 0. And so now I've got a line. Ooh, stop. Oh, that was close. Okay, less than or equal to. So it's a solid line. Oh, that was stressful, guys. Just so you know, I'm trying to make sure I don't do that again. As I said, I actually, yeah, I get how to do these, but I still make mistakes all the time, especially with the solid dotted line things. I learn things too. Like I learned There's something that I'm going to teach you guys next time, but yeah, at the moment we're just going to draw this up. I'm going to teach you guys next week, but yeah, we're going to stick to this first. Now, which side is the good side and which side is the dark side? The dark side, of course, of the force is we can choose any point to test. Well, any point that's not on the line. So I'm going to choose 0, 0. Why? Because it's just an easy point to choose. The only time you should not choose 0, 0 is if it goes through 0, 0. But yeah, so we're going to test. Is 3 times 0 plus 0 less than or equal to 9? Well, 0 is 0 less than 9. Yes, 0 is less than 9. So this is on the good side. So that means everything else is on the bad side. So that means everything else we cross out. All of these on this side will fail this rule. I can choose any point. I can choose 10, 10, 10, 10. If I choose 10, 10, we've got 30, 3 times 10, 30 plus 10 is 40. Is 40 less than 9? No, it's not. That's why only this region here. So now we're going to do the next equation. So the next equation is this guy here. Y is greater than or equal to, I'm going to do this in blue. Y is greater than or equal to 4 plus a half x. Or y equals 4 plus a half x. And we're going to plot this line first. Okay? So first we're going to plot that line. How do we plot this line? Well, this one we're not going to do the intercept method because it's already set up like this. We're going to do the gradient intercept method. So first we're going to find the intercept. The y-intercept is 4. C equals 4. And m, that's going to be 1 over 2. So we've got a rise of 1 and a run of 2. This should be a lot more familiar to you. Whoopsies, my screen's frozen. This should be a lot more familiar to you because we've done this. We've done this already. So we've done this in the last topic. So C equals 4. 1, 2, 3, 4. There is 0, 4. And then what we're going to do is we're going to run 2 and rise 1. So we go 1, 1, 2, and then we're going to rise 1. So that puts us about here. And then what we're going to do is once you've got that point there, you're going to check it's greater than or equal to, so I can do a solid line. I'm going to do a solid line straight through here. Now the last little bit we have to do for this, how do we get the last little bit? What we need to do is we need to talk about, well, we need to pick a point. We're going to choose 0, 0 because why not? Is 0, 0 in the light side or the dark side? How do we check? Well, we substitute in. 0 is greater than or equal to 4 plus a half times 0. A half times 0 is going to be, the question is 0 greater than 4? No, 0 is not greater than 4. So that means the 0 is in the dark side. So what we do is we shade it out. And that brings us to here. This region here is the feasible region. So I'm going to do a little thing here. I'm going to do a blank square. I'm going to write feasible region because that's our blank area. And then we can choose, and then we're done. That's now the question, the answer to that question. So at this point here, what we could do is we could, actually what I'll do is I'll quickly take a photo of this one too, just so that we've got it. what we could do is we could do the same thing we did last time, is we could choose a random point. We could check to see if it works. We don't have to do this, but I think I might do this really quickly just to show you guys, guess what? It still doesn't matter. We're going to choose, I'm going to choose this point here. So that point looks like 1, 5. So we're going to choose 1, 5. Firstly, is 1 greater than 0? Yes, it is. Is 5 greater than 0, greater than or equal to 0? Yes, it is. Is 3 times 1 plus 5 less than or equal to 9? Well, 3 times 1 is 3, plus 5 is 8. Is 8 less than 9? Yes, it is. Last one, if y, which in this case is 5, is greater than or equal to 4 times a half times, in this case, 1. 4 plus, sorry, a half times 1, which means is 5 greater than 4.5? Yes, it is. So it ticks, ding, 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 jackpot. It ticks all 4 of those boxes. Whereas if I chose another one from a different region, if I chose one from this region, it would fail. If I chose one from this region, it would fail this rule. If I chose one from this region, it would fail this rule. If I chose one from this region, it would fail both of those rules. If I chose one from this region, it would fail this one, and this one. So yeah. It's going. That's how we create a feasible region. Ladies and gents, that brings us to, and I believe it is 240. What I'm going to do now is I'm going to quickly go back over here. I'm just going to check to see if there's any. Oh, before I change back, are there any questions about this? Is there anyone like, whoa, can you re-explain this part or this part? Or the gradient intercept method, or how I did it? Are there any questions here that you guys are yearning for me to explain? Okay. Without that, then what I'm going to do is I'm going to quickly go here. So I'm going to check to make sure there aren't any more slides. There are not. So I only have 2 examples here, but I thought those 2 examples were interesting. I chose this one because I wanted to show you one where there was a gradient intercept method. But yeah, what I want you guys to do now is to give 12E a try. So